All right, so let's take a look at different types of catalysts. So the first type we're going to go over is homogeneous. In homogeneous catalysts, everything's in the same phase. So if your reactants are aqueous, your catalyst is aqueous. If it's a solid, it's a solid. Liquid and liquid, gas and gas, that kind of thing right there. And this is just a generic catalytic cycle here. So for us, we'll start off on this catalyst. So you see the catalyst is going to go in this kind of circle. It picks up reactant A, then it picks up reactant B, and then it turns it into product C. But the catalyst itself is rejuvenated and can go through this cycle again and again and again. So there's homogeneous. Next up, we have heterogeneous. So this time it's different phases, right? So they're not in the same phase. And in general, this is usually a solid catalyst interacting with a either gas, liquid, or aqueous reactants. So not always, but usually. And so there's a process to this. So it's kind of a 4-step process. The first step is adsorption, not absorption, but adsorption. So it's just adsorbing the reactants onto the surface of the catalyst. The second step is activation. It somehow activates the reactants to react easier. Then there's the actual reaction occurring. And then there's the desorption, right? The catalyst kicking off the products. So one of the probably most common example is the hydrogenation of carbon-carbon double bonds. So we have this carbon-carbon double bond, and we're going to add an H2 across it. And usually it's catalyzed by some kind of metal. It can be various different ones, nickel, palladium, some other ones as well. Not really important, the identity. But then our end product is these two singly bound carbons, and now they each have 2 hydrogens from it. So this is how they take unsaturated fats and make them into saturated fats, right? So we said the first step was absorption. I will actually just use this picture right here. So the first step here is absorption, right? So first these hydrogens get absorbed onto this surface, and then this ethylene, this carbon-carbon double bond gets absorbed onto it. Then this second step is some kind of activation here. And so basically what this is doing, this metal is interacting with this pi bond, this double bond, and making it easier to react. So now it's activated this compound. And you can see from this picture, we broke that double bond. And then in the third step is the actual reaction. So you can see the hydrogens are attaching themselves onto this molecule. And then the fourth step is desorption, right? This CH3, then leaving. So catalysts are very important in industrial applications, but also in your body. Your body has all kinds of biological catalysts in it. And these are called enzymes, right? So if you study biochemistry, you'll learn a whole lot of enzymes. Biochemistry is a pretty cool class. It's definitely more chemistry than it is biology, and a good foundation in general chemistry will really aid you well in understanding biochemistry and understanding the human body and medicine in general. So here's just an example of some enzymes and their functions, right? Oxioreductases, well, they do redox reactions, right? Transferases, they transfer things, and all kinds of different things, right? So there's just some examples for you. Here's a picture of how it works. right? So you have some kind of substrate. This is your kind of reactant up here, and then you have your enzyme. It's your catalyst, right? They've got to combine together, and then your catalyst is going to do something and then spit out some kind of products. Here's just another example, a bit more detailed of a picture, which kind of shows the importance of the chemistry of it a little bit more. So here we have sucrose, sugar. And when your body absorbs sugar, it's going to break it up into glucose and fructose, which then your body can use for energy. And so in order for that to happen, this molecule must fit into the active site of this enzyme. It does some kind of reaction and then kicks out the product. But the part that I really want to highlight here is that this enzyme is very selective for the shape of the molecule. Only things that are shaped like sucrose can fit into this molecule. So you can see why it's very important to know the shapes of molecules, which we spent quite a bit of time on earlier, well, probably not earlier in this course, but back in Chem 101. So you can really see how the foundations of chemistry are really what control what's going on in your body and in the world and in the universe.